All right, hello, good evening, guys. Happy Tuesday. Welcome back to our April week one. Okay, sorry if I sound a bit, I sound a bit coarse today. I'm actually not feeling very well. Okay, but hey, I'm still okay to have class, so hope you don't mind the low energy today. Feeling a bit tired, so all right, but class is still as normal. Okay, I'll try my best. Anyway, so thank you, please, thank you. I will. Right. We can see. Yes. Hello, Ying Hui. Is it your first day here? Is it your first time here? All right. This is still March notes, by the way. Hello, Ying Hui. How are you? This is March notes, by the way. You can look at my screen for now because we still haven't finished March notes yet. All right. We still have like one more lesson to go. Okay. I'm going a bit slow lately, so I hope I can speed up today. Right. So guys, I have mentioned a lot of history last week, huh? Okay, and I have taught you how to look at your periodic table. Okay, remember? And we have periods and we have groups. Okay, so like carbon, this is group 14. Okay, at the 14th column. And it is period 2. It is at the row number 2. Things like that. And we arrange everything according to proton number, which is our IC number. So this is IC number 1, IC number 2, IC number 3, IC number 4, IC number 5, 6, 7, 8, 9, blah, 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 all the way until IC number 180. So for now, we have 118 of elements that is around. All right, 118. Just like IC number lah. Okay, I'm sure in your class, guys. I'm sure in your class you have a you have you have a class list, right? And you have numbers, right? So number 1, I'm sure it's someone starts with A, and then number 2, number 3, number 4, and then let's say your class has 40 people, then you go all the way to number 40, right? So this is the same as it. Just imagine this is a class. Just imagine this is a class. Now you have numbers, you have ID number associated to every one of it. Okay, I've mentioned this. Yes, Jing, hello. Okay, hi. We just started. Don't worry. Don't worry. Okay, anyway, so we have finished this group 1. As I said, these are the batshit crazy elements. These are the batshit crazy elements, right? Because group 1, whatever it is, you throw them in water, they are going to explode. All right, you throw them in water. Did I just disconnect, guys? Because there's a blink on my screen. Sorry if I do. It's raining in my area here, so my internet is a bit. No, okay, cool. Right. So anyway, these are the crazy elements. Okay. So what you can see here, as they go down, the atomic number increase, their proton increase. Okay, proton is the atomic number, and then the mass number is the proton plus neutron number. Okay, they increase as well as you go down. They become bigger as you go down. So you see, lithium is the smallest. So sodium is bigger, potassium is bigger. You might say, sir, why don't we study rubidium and cesium? Guys, these two, we don't mess with them because they're freaking crazy. Potassium is crazy enough. You put them in water, they explode. So if you deal with rubidium and cesium, you might die, right? So we don't mess with them. Okay, hello Terence, how are you? Okay, so as you can see, the boiling point decreases, the melting point decreases as well. Okay, guys, you don't need to pay too much attention here. You will be learning this in year 10 chemistry, which will explain why does their melting point and boiling point decrease. You will learn it in year 10. Okay, so we're not going to go too deep into this. Okay, so yeah, as I mentioned last week, you can kind of predict what happens to rubidium. Okay, when you look at the melting point and boiling point, you can see that they don't go down as you go down the group. Okay, they decrease as you go down the group. The next metal is rubidium. We can predict it would have a melting point lower than 63. It would have a boiling point lower than 777. So this is a trend, we call it, right? This is what we call a trend. Okay, so as you can see, we have to keep them in oil They are freaking crazy. They will explode. Even with air, even they touch air, they will catch fire. So they have to be kept in oil. All right. So so what are their uses? Okay, what are their uses? Okay, so I want you to focus here. I want you to focus here. Try not to focus too much on the chemical properties because this is not really your level. All right, this is not really your level. All right, so what you want is this. Okay, what is it? Oh, Yinghui, have you learned this? Yinghui, have you learned this in school? Have you learned this in school? For the fact, any of you learned this in school already? Or any of you haven't learned this in school? The group 1 and then your groups, group 2, group 17 and group 18. Any of you learned it in school already? Oh, okay, didn't learn the use. Okay. Oh, you guess. Okay, learn, huh? Because next year, when you go year 10, you are learning the exact same thing. The intro to chemistry, the first 2-3 chapters, you'll be learning this. So this is like a sneak peek lah. This is like a 先给你学先，你明年再学多一次，something like that. Okay. Anyway, so let's look at our lithium. Okay, guys, lithium is what we use in battery. Okay, we use in battery. Medicine to treat mental disorder, not so important, but the main point is battery. Your batteries are all lithium. Okay, I don't care something as small as a smartphone or something as big as a Tesla, right? Guys, if you buy a Tesla, if you buy an electric car, it's still made from lithium. And you might say, sir, didn't you just say lithium is crazy, they will explode? Yeah, that's why battery, they caught fire. Battery, they will catch fire. Okay, this is why Samsung Note 7, it caught fire. All right, and Samsung just kind of canceled the phone because they didn't want to get sued, so they just kind of canceled the phone. All right, so as you can see, lithium is very dangerous. So guys, if you have a lithium battery, please don't poke it. If you poke a lithium battery, they will catch fire. All right, then you might say, sir, why are we using lithium then? Why can't we use other stuff? Because lithium is very cheap and lithium holds a lot of charge, right? Lithium can last very long. This is why your phone battery lasts for very long. Okay, you might say, sir, my phone battery doesn't last very long. That's the longest already. Okay, so that's your lithium. And sodium, metallic sodium is used in certain kind of street lamps. Okay, this is what we call a sodium lamp. You know this orange lamp? I mean, we don't use this anymore. We don't use this anymore. But last time, or you go to some old cities or you go to some old towns, you still see the street lamp in orange, right? That's the sodium lamp. Okay, that is the sodium lamp. I mean, we don't use it anymore, but because this is not very good in terms of brightness. Last time, I'm sure you have seen this before in the streets. Yeah, there. This is like the old school street, right? I mean, nowadays we don't use this. Nowadays we just use LED, right? We are just using LED nowadays. So on highways, we see white. Because they kind of cancel away the sodium lamp already. Okay, and sodium hydroxide, this is used to make soap. Okay, quite important. You'll be learning this in year 10 chemistry. In the body, sodium ions are needed by your nerve cell to transfer nerve impulse. Guys, your nerve uses sodium to work. Your brain uses sodium to work. That's why salt is very important. You get your sodium from your salt. Right? Then you might say, sir, you say sodium can explode, right? Won't salt explode? No, because sodium will explode, yes. But salt, I'm sure you know this, salt is sodium chloride. Okay, which I'll talk about the chlorine later. When group 1 reacts with group 17, they just become best friends. They just become a very cute couple. They won't explode anymore. Okay, that's the way it is. Right, I'll talk about that later. So potassium, we use this as fertilizer. Potassium nitrate is a fertilizer. Okay, and fun fact, guys. Fun fact. Do you know where else we use potassium nitrate? Do you know where else we use potassium nitrate? Potassium nitrate is actually explosive. Potassium nitrate is actually explosive. So we use them in gunpowder. All right, gunpowder. You must say, sir, that means gunpowder is a fertilizer? Yes, it is. Yes, it is. Gunpowder is a fertilizer. Okay, isn't it amazing? Right, chemistry is a very funny thing. Right, so in the body, potassium ion are used for the control of the water content of the blood. and used with sodium ions in sending nerve impulse. So sodium and potassium, as dangerous as they are quite important in our body. Quite important in our body. If you have too much, if you have not enough sodium, you will cramp. You will cramp. You run halfway, then your muscle cramp. If you have not enough potassium, your heart will not work. Your heart will stop pumping. So you see how potassium and sodium is quite important. Yeah, they are dangerous, but we still need them. We need them in small amount in our body. Okay, wow, the more you know, huh? All right, anyway, so the structure of group 1 elements. Okay, let's look at this. You'll be drawing this in year 10 next year. I don't know about this year. Most likely they won't ask this unless your teacher is crazy. So lithium has an atomic number 3. This is how much proton they have. Remember I said atomic number is their proton number, is their IC number. All right, they have the mass number of 7. This atom contains 3 protons. As I said just now, this is the proton number. So they have 3 protons. And since proton and electron is the same, so they have 3 electrons as well. 3 plus 3 minus. 3 proton means 3 plus, 3 electron means 3 minus. And then the remaining 4 is neutron, because 3 plus 4 is 7. The mass number is 7. Like I said, the mass number is proton plus neutron, right? Proton plus neutron. So 3 plus 4, you get 7. All right, so this is how you draw it. The electrons are arranged as 2.1. Okay, guys, have you learned this in school? What is 2.1? Some teacher, they will teach this, some they won't, because this is more about our syllabus stuff. This arrangement of electron is known as the electronic structure. Okay, so let's look at this. 3 electrons are, okay, first of all, can you see these circles? We call them shells. Okay, we call them shells. And let's talk about shells. Okay, let's talk about shell. The first shell, oh, you have learned the first shell, you can put 2 electrons. All right, and the second shell, you can put 8. And the third shell, you can put 8 as well. And the fourth, you can also kind of put 8, but usually they won't ask beyond 3 because it's not in your syllabus. So you see, I have 3 electrons, right? I will fill the first shell first. So I have 3 electrons. I will fill 2 here, and it's already full. I cannot put 1 more here. So the next one, I'll put it in the next shell. So for lithium, this guy has 2 shells. 2 in the first one, 1 in the second one. So we just call it 2.1. Okay, by writing 2.1, I can know, oh, this guy has 2 shells. This guy has 2 on the first shell and 1 on the second shell. You guys okay? You guys okay? This is actually year 10 stuff, but it's good to know, but because next year you're learning anyway. All right, so, and of course, let's look at sodium. Let's look at sodium. Sodium has 11 proton and 12 neutron. Okay, so the atomic number is 11, mass number of 23, so it has 12 neutrons. All right, so since I have 11 now, right? I have 11, right? So the first layer, I put 2. Okay, and then the second layer, I put 8. 1, 2, 3, 4, 5, 6, 7, 8. So 2 plus 8 is 10. I have 1 more remaining, so I put it at the third shell. You guys okay? You guys okay? This is like basic maths. Okay, so I put 2. Now I have 11 balls. I have 11 balls. The first bucket, I can put 2. Second bucket, I can put 8. Then I have 1 more remaining. I put it at the third bucket. Just imagine shells as buckets. The first bucket can put 2. Second bucket can put 8 and 8 and 8 and so on. So I fill the first one first. When the first one is full, I fill the second one. When the second one is full, I fill the third one. So I fill up as I go. All right. So, and please take note how to draw them. Okay, my say, sir, why is it a cross here? Can I just draw circle instead? Yes, you can. Yes, you can. You have a choice of either circle or cross, but I just think cross is easier to draw. All right. And can you see they are in pairs? Okay, you see the first shell, the first layer, the 2, they are kind of opposite of each other. Because you see, electron, they're negative, they don't stick to each other. Negative, they don't become good friends. As a guy, you are more attracted to a girl rather than a guy. And as a girl, you're more attracted to a guy rather than a girl. Okay, guys, chemistry has no gay or LGBT. You don't come. Sir, guys can marry guys. Yeah, in real life, yes, but in chemistry, no. All right, no LGBT here. Okay, so negative and negative, they don't really like each other, so they're opposite each other. Okay, and then for the second shell, you have 1 pair, 1 pair, 1 pair, 1 pair. You may say, why now they together? This one they have no choice. This one they have no choice, so they are in one pair, one pair, one pair, one pair. Guys, please don't be cute. Please don't be cute and like, oh, so I'm just gonna draw it this way because it looks nicer. I'm just gonna spread this thing around. No, this is wrong. Okay, no, this is very wrong. You have to do it in pairs. Okay, don't ask me why. The chemists, they make the rules, not me. You just need to follow. All right, and then potassium, it has 19 proton and 20 neutrons. All right, so now I have 19 balls. So how do I put it? First bucket, I put 2. Second bucket, I put 8. Now I have 10. Third bucket, I put another 8. So now I have 18. Okay, so I have one more remaining. I put it at the fourth bucket. So you have 2, 0.8, 0.8, 0.1. All right, so you can see here, I have 4 shells. I have 2 on the first shell, 8 on the second shell, 8 on the third shell, 1 on the fourth shell. Okay, and that's how you draw the electron arrangement. This is what we call an electronic structure. Or we just say the arrangement of electron, the electron arrangement. All right, you guys cool? Usually they won't ask this in your exam yet because you're in year 9, but this is part of the textbook. All right, so they have a chance of asking this. So I mean, don't pay too much attention to it. Okay, you have to know, but you don't need to pay too much attention because next year you are learning this anyway. Okay, cool. You guys okay? Are you okay? Are you following along? Okay, cool. All right, so moving on, let's go to group 2. Oh, this is interesting. Right, see, group 2, we call it alkaline earth metals. They are still alkaline. Just now, group 1 is alkaline metal. This is alkaline earth metal. All right, they are not as crazy as group 1. This is less crazy. Right, group 1 is freaking crazy. Group 2 is okay crazy. They still catch fire, but it's not that crazy. Right, these metals are not alkalines, but their compounds dissolve slightly in water to make alkaline solution. Okay, cool. You don't need to know. Okay, melting point decrease as well. Boiling point decrease as well. Same as what you see up there. Oh wait, they decrease first, then they increase. This is a bit funny, right? You don't ask me why, guys. This is on your syllabus. Right, so chemical properties, they are less reactive. This is what you need to know. They are less reactive than alkaline metals. Okay, do you know why? Have you learned why are these elements so crazy? Have you learned it in school? Because of that one electron. You see, okay, as an atom, let's say if I'm an atom, my job is to reach full outer shell. You get what I mean? As an atom, my job is to become full. Okay, 我的外面那一层越满越好。Okay, yeah, you can say that. This is outermost is 1, right? That's why they are group 1. Oh, you learned this already? You've learned this before? Okay, so my job is to become full. All right, so as a lithium, how do you become full? There's 2 choices here. Either you can take 7, or you can throw this one away. Because think about it. If I throw this one away, this second shell is no more. Now my outermost is 2. I am very happy. Same goes to sodium. You see, if I throw this one away, the third shell will disappear. My second shell will become full. Very happy. Same thing in potassium. If I throw the outermost one away, the fourth shell will disappear. I have the third shell as the outermost, so my third shell has 8. Also very happy. So guys, let me ask you, if you have one imperfection, will you correct that? You get what I'm trying to say here? Guys, you look at people who do plastic surgery. Okay, I like to use plastic surgery as my analogy. You look at people who do plastic surgery. Usually they are already very pretty. 是吗？整容的人都是很漂亮了的， so they are already very pretty. But they are almost becoming more pretty. So you will want to do it even more, right? Imagine you look perfect, your face is perfect, but your nose is not very nice. So what do? You will die, go and fix your nose one, right? Because compared to other people, if you look ugly as shit, okay, I'm sorry to say that, if you look ugly as shit, your eyes, nose, mouth, everything ugly, you're like, aya, chincai lah, no need to plastic surgery. I got so many things to fix myself, I don't do. Right? So this is the thing. If you are one step away from perfection, you will be very desperate to fix this thing. You get what I mean? You get what I mean? If you have a very pretty car, there's a scratch on your car, the scratch will be very freaking obvious. You will die fix the scratch. But if your car is already beat up, the paint is like shit already, wheels are fallen off, aircon doesn't work, you're like, aya, chincai lah, this car also like shit already, I don't want to fix lah. Right? So this guy and these guys, they're like one step away from perfection. So they say, I must do it. I must throw that one away to become perfect. So that's why they are freaking crazy. That's why they are freaking crazy. But for group two, you see how many they have on the outermost? Okay, I didn't show it here. Group two, they have 2 on the outside. Like you see, let's say beryllium, okay, beryllium is 2.2. Beryllium is 2.2. So you see, they have 2 to throw. I mean, if you have 2 imperfection to fix, you're like, okay, you chill a bit, right? Because you're 2 steps away from perfection. But this guy is 1 step away. That's why lithium is crazier than beryllium. All group 1s are crazier than group 2. Group 1全部是神经病的，他们差一步就要完美了，所以他们死都要完美咯。You get what I mean? You get what I mean? Okay, so beryllium does not react with oxygen in the air. I see, they don't even react with oxygen. But these 3, the group 1, they will react with oxygen. Okay, magnesium, calcium, strontium forms metal oxide on their surface. Barium must be stored in oil to prevent rigorous reaction. Okay, only barium you need to store in the oil. All right, so they, you don't need to know this. They burn in oxygen to produce oxide. And guys, funny enough, when you burn group 2, okay, when you burn group 2, you will get a lot of color. You see? When you burn group 2, you get many colors. That's why guys, group 2, mostly we will use them in fireworks. We'll use them in fireworks. If you buy the cheap fireworks, the you like that one, the like that one, not the nice round one. Okay, I'm sure Chinese New Year you play firecracker, right? Okay, the fireworks, usually you will see green and red, right? It's usually these 2 colors. Okay, maybe you have purple. So the green color is usually barium. You see, barium is green. And the red is usually strontium. And then next to barium is strontium. So these 2, usually we use it to make fireworks. And if you use purple is potassium. Purple is potassium. That's why if your firework has purple color, it is slightly pricier because potassium is a little bit more expensive. Strontium and barium is very cheap. That's why if you buy the cheapest fireworks, you only see red and green because very cheap. So only nicer one you see purple. Okay, things like that lah. All right, anyway, so let's look at where do we use them. So beryllium, okay, this is very interesting. Beryllium combines with aluminum, silicon, and oxygen to form a mineral called beryl. Have you seen this before? Does this appear in Minecraft for any reason? I'm sorry guys, I don't play Minecraft, but many of my students, they do. So whenever I mention some kind of mineral names, they say, oh, sir, this is in Minecraft. Is this in Minecraft? I know obsidian is, right? I mean, I don't play Minecraft, but whenever I mention obsidian, my students will go crazy. Oh my God, sir, obsidian, I know, this appeared in Minecraft. Okay, cool. Right, anyway, so emerald and aquamarine are also 2 gemstones of beryl. Okay, beryl has actually a few types. You have the expensive beryl and the cheap beryl. Okay, you know what is emerald, right? You know what is emerald? This is what we call in Mandarin 祖母绿. Okay, it's a type of instead of gemstone. Oh, hey, it appeared in Minecraft. Okay. Just I was talking about this. Right, guys, emerald is freaking cool. Emerald is freaking cool. Okay, they are kind of transparent. They're kind of transparent, and it depends on the grade though. Okay, the deeper the green, the more expensive they are. Very pretty, yeah, very pretty. Okay, so that's your emerald, and of course, aquamarine. Aquamarine is more like a aquamarine. This is more like a, what's the color called again? What's the color called again? The Tiffany blue color. What is it called again? Aquamarine lah. Okay, a little bit like emerald, but it's slightly bluer. Okay, what is this color called again, guys? For the life of me, I can't remember the color. Sorry, I'm a bit sick today, so my brain is not functioning very well. Okay, anyway, so those are your minerals lah. Okay, and of course magnesium, we use it to fireworks to make bright white light, as you can see. Guys, please don't look at magnesium when they burn. You're going to hurt your eyes. They are so bright. They are so bright. We used to use them in camera flash. Like 100 years ago, back when camera was still very lao ya, the time we have no light bulbs. When light bulbs haven't invented yet, we use magnesium as the camera flash. Okay, so the more you know. Anyway, and of course, we have another important use is to make strong and lightweight alloys. All right, our car sports rim. Any of you interested in cars? If your car sports rim is the lightweight one, it's usually mixed with magnesium. Right, same goes to bikes. Same goes to bicycle. If you buy those competition bicycle, like 20, 30,000 per bicycle, they will usually use magnesium alloy because it's very lightweight. Yes, you heard that right. It's 20, 30,000 for one bicycle. Bicycle, not even motor or car, it's a bicycle, it's 30,000. You know what 30,000 can buy? 30,000 can buy you a Product Asia already. You're buying a bicycle. Okay, for rich people, or you want to go competition. Okay, hi Jaden, how are you? All right, so calcium is found in baking powder, bleaching powder, everywhere. Guys, your teeth is made from calcium. Your teeth is made from calcium. Calcium is required for formation of healthy teeth and bones for the contraction of muscle, but mostly for teeth and bones. All right, guys, your nails, yeah, sure. Okay, your nails is calcium. Even the rhino's horn is calcium. Guys, do you know humans, we hunt rhinos for their horn? Do you know that? Do you know that? I think it's pretty stupid because according to some Chinese medicine, according to some Chinese medicine, according to Zhongyi, they say this rhino horn, if you grind it to powder, you can cure cancer. Guys, this is why you learn science. Don't you find it stupid, right? To say that the horn cures cancer, all right? It says that it means that calcium cures cancer. Might as well, you eat your nails, right? No need to go and kill rhino. Next time you clip your nails, right? You put your nails onto the pestle and mortar and you grind it to powder, then you drink it. It's free. It's free. You want mine? I can give you mine. I can give you mine, right? Because I'm throwing it anyway. Okay, or if you say, sir, nails very dirty, then you eat eggshells. Eggshells also the same one. Right, so next time you make hard-boiled egg, don't peel the shell. Just eat together with the shell. Free calcium. Why do you need to kill rhinos? So they die for nothing, right? Rhinos, they are currently going extinct because there are still stupid people believing that, oh, the horn can cure cancer. So sometimes people ask me, sir, why do you teach science? Why do I need to learn science? I learn science for what? So that you don't turn into someone stupid and you hurt other animals for no reason. All right, just eat your nails. Eat your nails. You bite your nails, okay? If you say, sir, I only got 10 nails, and then bite your finger, bite your toenail also, you have 20 now. So stupid, okay? Really stupid. Right, anyway, so by the way, this is what we call limestone. Limestone. This is what we call calcium carbonate. This thing is made from calcium. All right, you know Batu Cave? You know Batu Cave? The whole Batu Cave is a limestone. It's a big limestone, so pretty. And if you go to Ipoh, if you go to Ipoh, you go to Ipoh, next time you pass by the highway, you will see those limestone at the side, right? Right? Every one of it is like limestone. All of these are limestone. So pretty. So you might find marble inside. Marble is from my limestone. You know marble? You know marble? You want to flex your house very, very wealthy, very rich, you put marble everywhere. So marble is from limestone. That's why they're very expensive, because they are buried deep underground. Okay, anyway, so group 17. So this is your halogen. All right, I already give you everything here, the electronic structure. Okay, the chemical properties. Okay, this is another crazy group. Okay, you see, group 1 is crazy guys, crazy males, crazy guys. Group 17 is crazy girls. All right, so they are, you see, freaking vigorous. They react like crazy. Chlorine dissolved in water to form hypochlorous acid. You know what is this? This is bleach. Guys, 15% of bleach can kill you just by drinking it. Okay, so you want to kill yourself, drink bleach. All right. Bromine also dissolves in water, but form, okay, also very vigorous. Iodine also freaking crazy. All right, so where do we use it? Fluorine, we put it in drinking water to prevent tooth decay. Our tap water, if you switch on the tap water already has fluorine. This is to make your teeth strong. Your toothpaste have fluorine. Right, and then chlorine, this is bleach. Okay, also to kill bacteria. You know, your swimming pool has bleach, so that's a chlorine. Bromine is the same thing. But something funny, you see, this is interesting. Silver bromide is what we use in photographic film. You know, photographic film. You know what's a Polaroid? You know, last time those old school camera you take already, they will print one, then you have to shake it one. Yeah, the one is silver bromide. That was silver bromide. Okay, so anyway, let's look at them. You see, fluorine is 2.7, chlorine is 2.8.7. You see how crazy they are? Right, you see, fluorine is also one step away from perfection, isn't it? I just need to get one. Okay, chlorine, same shit. I also need to get one. Right, so now you see how chlorine and sodium, they are perfect for each other. Sodium die wants to throw one, and chlorine says, hey, you want to throw one? Why don't you give it to me? All right, that's why sodium and chlorine, yes, they are like this crazy guy and this crazy girl. Okay, they both hate the world. All right, they both hate the world, and then they found each other and they fall in love, and now they are both happy. Yeah, so cliche, right? But this is the best analogy I can give, right? Crazy guy sodium, crazy girl chlorine. I'm so mad at this world because I'm not perfect. Hey, we made each other perfect. Okay, cool, right? So next time, go and tell your girl or tell your boys, I'm a chlorine. Would you be my sodium? You see, we study science one, our pickup line is not those lame one. We use science one. Okay, I'm a sodium and I'm a sodium and I found my chlorine. Yeah, so disgusting. Okay, anyway, moving on. Okay, so group 18, noble gases. Okay, noble gases. Okay, these are the least crazy one, guys. Why do we call them noble gases? You know who are the nobles? Yeah, exactly. Like you remember the Vena Amoris I told you last week. You see, tell that to girls. Girls dig that shit. Okay. Anyway, so noble gas. You know it's noble. Noble means 高贵. Okay. You go back to 500 years ago. Nobles are the people of nobility, rich people, right? Like you are related to the king. You are related to the royals. You are a nobility. Right? You are the rich people. Okay, us, we are peasants. All right, we are peasants. Unless you're like the top 1% richest person in Malaysia, then you are the noble. Right? So why do we call them noble guests? Because they don't react with anyone. Noble gases will just stand on their moral high ground and judge you and say, oh yeah, look at all these cheap people. Look at sodium, so cheap. Look at chlorine, so cheap. Yeah, I don't know why they, 做么他们这样缺爱，做么要 react 来 react 去 ？Why are they so desperate? Noble will say, look at all these poor people, right? So the noble gases are very unreactive. See, very unreactive. Some of their uses are listed below. Okay, so you see, helium is 2, neon is 2.8, argon is 2.8.8. Are they full? Are they happy? Yes, very. Already full, already full, already full. Helium, neon, argon, they are already bond perfect. Okay, so if you go neon and say, can I give you 1 electron? Neon say, look at you, I don't want you. Right? Or you say, hey neon, can you give me 1 electron? Who are you, man? Get away from me, you dirty peasant. Right? So they don't mess with cheap people like us, right? So they are called a noble gas. Noble, right? And you see, they even sit at the most right side of the table. Okay, it's like if you go to your school, right? You go to private school, right? You have those very rich kids, okay, are you one of them? Okay, you are those very rich kids, you only mix with rich kids. You guys will sit on the same table, the same row. All these filthy, dirty peasants, all these poor peasants, you're like, you guys can go to hell, right? Because all these they will react. All these elements they'll react. These they won't. Noble gases they just sit beside and say, no thanks, right? Okay. Anyway, so what are they? Okay, they have uses too. Okay, they have uses too. All right. So like helium, we use this to fill balloons. Right? Helium is lighter than air and is used to lift meteorological balloon into the atmosphere. These balloons collect information for weather forecasting. It is also mixed with oxygen to help deep sea diver to breathe underwater. Right, guys? Helium is what we put in balloons. You know those birthday balloons that floats? You know, and when you inhale them, you kind of talk like a chipmunk. Right? So helium, they are very stable. They won't explode. Right? I have students asking me, sir, helium is the second lightest. The lightest is hydrogen. Why don't we fill balloons with hydrogen? Because you see, hydrogen is very explosive. Hydrogen is very explosive, right? Unless you want to burn the person or you want their eardrum to pop, fill your balloon with hydrogen, please. Right? You can always say it's a prank, am I right? While killing the person, right? So helium is used in balloon. Neon is used in red lights. Okay, guys, we don't use neon anymore. You know what are neon signs? We used to use them in the 80s. Okay, neon signs. Now it's like making a comeback. You see, these are neon signs, right? And they have the sound, right? Nowadays don't have lah. These are just LED, right? Neon is like obsolete old technology already. So that's your neon. Okay, argon, krypton, xenon, we all put them in lamps. Okay, in fact, we all put them in lamps, right? Because neon is the advertising lamp. Argon, krypton, xenon are normal lamps. Okay, but we don't use them anymore. We just use LED today because it's just much better. All right, so you can just read this yourself. Not very important. Okay, so helium has an atomic number of 2. Okay, and 2 protons, 2 electrons, 2 neutrons. The shell is full. All right, the shell is full. For neon, it has 8 in the second shell. Outer shell is full. For argon, it has 8 on the second and third shell. The outer shell is full. All right, so every one of these people, they are happy people, they are perfect people, they are rich people. They don't mess around with poor people because they are already rich. Okay, you guys cool, huh? You guys cool, huh? So chemistry is not that hard, isn't it? Chemistry is really easy. Okay, so anyway, so guys, don't go too deep into this chapter. Don't go too deep. You just need to touch the surface. All right, because this is to prepare you for your year 10 next year. Next year, you'll be doing it in deep. Now it's still okay. Okay, we're still chilling. Okay, so let's look at page 9. Let's look at question number 1. I'll try to finish this by today if I can. So this is a basic helium atom. So X, it's your electron. And let's just say this is positive. Sorry, this is too dark. You cannot see. So Y is positive, right? So this is our proton. and Z is our neutron. You should be able to tell them who is who. Okay, and if you have 2 proton, you should have 2 electron. All right, 2 plus, 2 minus. Okay, that's how it goes. All right, so B, state the subatomic particle. These, okay, I forgot to mention, my mistake. These are what we call subatomic particles, right? Because this is an atom, right? This is an atom, right? Inside an atom, we call it subatom because sub means inside. Okay, so subatomic. What is inside an atom? All right, so state the subatomic particles located in the nucleus. So where is the nucleus? Nucleus is in the middle. So in the middle, you have your neutron and you have your proton. So proton and neutron. All right, guys, do slow me down if you feel overwhelmed. If you feel this is difficult, please let me know. Don't be shy, okay? Slow me down. All right, I'll explain it to you. And state the subatomic particles which has the following property. Okay, who has no charge? Who is neutral? Neutron law. Neutron is neutral. You see how it works? And then negatively charged is your electron. Positively charged is your proton, because pro is positive. Pro, positive. Positive charge. Able to move, there's only one guy moving here. That would be your electron. Only electron is movable. Okay, so next, number 2. So you'll be seeing this a lot, questions like this a lot in the exam, right? They will give you a periodic table and then they will ask you things like that. Right, so Zubair drew an empty periodic table in his exercise book. What is a periodic table? Okay, it is a table arranging all elements, okay, according to their atomic number. Okay, so this is atomic number is proton number lah. So if you don't want to say atomic number, you can say proton number. So we arrange them according to proton number. So proton number 1, proton number 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Right? Remember how to read your periodic table from left to right, from top to bottom. Just like how you read a book. You see, you read your book from left to right, from top to bottom, right? That's how you read your periodic table. Exactly the same way. So identify the location of metals, semi-metal, and inert gases. All right, inert gas is noble gas lah. Same thing. So where is your metal, guys? Where is your metal? Your metal is over 1, 2, 2, 2. Okay, so your metal is over here. Okay, like I said, you don't need to memorize the periodic table. Guys, I hope it goes without saying. I've said it millions of times and I'll say it again. Please do not, I repeat, do not memorize the periodic table. There is no need to. Okay, unless you want to do it for fun. Sir, I just memorize it for fun. Yeah, sure, go ahead. All right, if it makes you happy. But there is no need. Seriously, don't memorize this. They won't come out in exam. Just to let you know. Okay, so your metal is on the left-hand side. Okay, can you see the green color? The green color are the semi-metal. So I just remember it as 1, 2, 2, 1. Okay, 1, 2, 2, 1. So the pink color one is your metal. Okay, somewhere there lah. Okay, mine is not very accurate, but as you know, it's on the left-hand side. Okay, it's on the left-hand side. Semi-metal is the one. Okay, let me change color. Semi-metal is 1, 2, 2, 1. Oops, I missed a few here. All right, so where is your noble gas? Where is the most action gas, the most lancy gas? They are here. They don't give a shit about you. They are rich people. All right. Okay, cool. You just need to know where's the metal, where's the non-metal. Actually, This is the semi-metal, right? This is metal. Now this is the non-metal. And don't forget, you have one more non-metal here. Hydrogen is a non-metal, although they are on the left side, but they are a non-metal. One exception. All right, the rest of it all. Okay, I just remember it as like this: 男左女右. Because in Mandarin, okay, if you speak Mandarin, we say 男左女右. Guy on the left side, girls on the right side. It's like watch law. Okay, as a guy, I don't know about you lah. Guys will wear watch on the left hand. Girls will wear watch on the right hand. Is it like that? I don't know lah, because that's what I know. So I say 男左女右. So guys on the right. Okay, guys are metals, and girls are the non-metals, so girls are on the left. Sorry, on the right. Okay, that's how I remember. Anyway, so number 3. So neon is a noble gas. It has the electronic structure 2.8. So which is the electronic structure of neon? Wow, this is so easy. This is 2.3. So this is out. This is 2.7, also out. 2.8, this is it. 2.1, this is out. Okay, you don't tell me you don't know how to count this. You cannot count crosses or circles, then I worry for you. So B, how many protons does the atom of neon have? You just add everything like, okay, it has 2, you see, 2 plus 8, it has 10 electrons. When you have 10 electrons, similarly, you would have 10 protons. Okay, so 10 protons. Right? 10 plus 10 minus, okay? 10 plus 10 minus. That's how it works. All right, so neon is in the group, sorry, this is group 18, is at the last. Other gases in the group of the neon, helium, and argon. Okay, so this is a redundant question. So see, the elements in group 8 are sometimes called the noble gas or inert gases. Helium has only one shell of electrons, neon has 2, and argon has 3. What do the shells of this group have in common? Okay, so what do the shells have in common? Okay, they have full electron. Okay, they have full amount of electrons. Okay, that means they are full on the outside. 2, 8, 8, 8, everything is full. So they're very happy. So D, how are the elements in group, 18, different from all the other elements in periodic table? Okay, they are very stable, will not react with any elements. Okay, used to make light bulbs, things like that. But the main point is very stable. Group 18 is very stable. Not group 8, guys, it's group 18. Because if you count all the way here, okay, if you count all the way here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, we call it 18 because it's at the 18 row. Okay, so next. Table below shows the characteristic of some elements in group 1. So you have lithium, potassium, and sodium. The crazy people, remember? Where in the periodic table do you find these metals? They are in group 1. What? That's the answer. That's the answer, group 1. So B, what is the trend shown in the boiling points of the group 1 elements? Okay, so our trend, how are they like of the boiling point? So you just see, what are they doing? It is decreasing, isn't it? Okay, it is decreasing. Okay, decreasing down the group. Because this is down the group, so it's going down. Down the group, it decreases. So see, what prediction can you make about the boiling point of rubidium? We just mentioned this in our notes, isn't it? If rubidium is here, what happens to the melting point? It should be lower. What happens to the boiling point? It should be lower as well. So it should be lower than potassium, right? Maybe this is 30 something. Maybe this is 500 something. I'm just guessing, right? I'm just guessing. This is just playing a guessing game. Right? You don't need to know the exact figure. So D, how many more electrons that lithium, sorry, how many, is it that? How many more electrons than, oh, sorry, this is that, sorry, there's no typo here. How many more electrons than rubidium does an atom of sodium have, right? So lithium has 3 here, right? Sodium has 11. So lithium has, sodium has 8 more, right? Because 3 plus 8 is 11. All right, this is primary school maths. So E, what happens to the size of the atom as it goes down? They increase. All right, they have more electrons as you go. This is 2.1, 2.8.1, 2.8.8.1. You see, I add one more shell as I go down. Of course, they become bigger. Right? So F, what similarity is there in the structure of these atoms? Okay, how are they similar? They have one electron on the outermost shell. Or, okay, guys, pay attention here. Pay attention here. Let me introduce a word. Let me introduce you a word. The outermost shell, the one on the most outside, we call it a valence shell. All right, we call it a valence shell. So these electrons, naturally, I call it valence electrons. All right, so for this guy, it has 8 valence electrons. This guy also has 8. This guy has 2. So on the outermost, we call it valence electron. Instead of outermost electron so long, I just call it valence electron. It has, so for this one, it has 1 valence electron. Okay, learn this word. Learn this word. Helps you a lot in year 10 next year. All right, so suggest why this group of metal is called group 1, because this is the same explanation. It has 1 valence electron. All of them have 1, that's why it's group 1. All of the group 18 one have 8. You might say, sir, why 18 is not 18 leh? You see, this is group 18, right? This is group 18, right? Why the outermost is 8 leh? Because you see, guys, from group 3 to group 12, we usually skip. Okay? This just let you know, group 3 to 12, we usually skip. That's why we go from 1 to 2 to 13, 14, 15, 16, 17, 18. We usually ignore group 1 to group 12. So we straight away go from 1 to, so group 1 has 1 valence electron, group 2, 2 valence electron, group 13, 3 valence electron, 4 valence electron, 5, 6, 7, 8. So we just skip 3 to 12. Don't ask me why. Okay, don't ask me why, because the group 3 to 12 one, they are very confusing, so we don't learn them. Okay, unless you go to A levels next time. All right, so H, what are the trends in the structure and behavior of this group 1? I already mentioned this, so I'm going to skip this. Boiling point decrease, melting point decrease, atomic number increase, mass number increase. All right, so let me just give you the answer for number 5. Are halogens metals or non-metals? They are non-metals. What is the trend of this melting point? So the melting point increase, right? From negative 220 to negative 101 to negative 7, it increases, right? So it increases. Boiling point increase as well. From negative 188 to negative 34 to 59, it increases as well. D, what would you predict about the boiling point and melting point of iodine, the next element? So iodine is not here, right? So what do you think the boiling point, the melting point is? Of course, it increases. It will be higher than bromine. All right. What would you expect iodine to be more or less reactive than bromine? Okay, the lower they go, the less reactive they are. This is very dangerous. This is less dangerous. This is even less dangerous. Iodine is even less dangerous, so they will be less reactive. All right, that's why iodine can be put on your skin. You know the yellow color medicine, the 黄药水. When you fall down, you put some kind of yellow medicine on your wound. That's the iodine. So F, what happens to the size of the atom as you go down? Of course, it increases as well because I have more shells. 2.7, 2.8.7. Oh, it's already here. 2.7, 2.8.7, 2.8. You might say, sir, why got 18 here, man? I thought you say third shell got 8. This is not your syllabus. This is not your syllabus. You might even see 36 there. Right? Don't ask. This is college chemistry already. So G, what similarity is there in the structure of these atoms? Okay, they have 7 valence electrons. Why is this group called group 17? Because they have 7 valence electrons. And that's it. All right. Oh, finished just in time. Right. So guys, do you have any question? Do you have any question? Guys, if you need this video, you want to watch it again, kindly come and get it from me. Okay, kindly WhatsApp me. Okay, and for those who just came in late just now, please WhatsApp me. This is my phone number. I will send it to you. All right, you don't need to request, fill up any request form. Just WhatsApp me. I will send it to you. You can watch it how many times you want. Right, I'll put it on YouTube anyway. Private YouTube lah. Okay, you just watch how many times you want. Okay, so you guys okay? You guys okay? Yinghui, are you okay? This is your first class, so hopefully you're okay. So guys, next week we are going to April notes. I hope you have received yours. Okay, so I will see you next week. Okay, guys, have a good Tuesday. I'll see you soon. Take care. See you. Bye-bye. Thank you for listening. Bye-bye.